Dear students, today we'll discuss on dual converter fed separately exited DC motor drives. In the previous class, we have solved some numerical problems based on three-phase full and half controlled rectifier fed separately exited DC motors. So we have calculated what should be the firing angle alpha for the controlled rectifier to obtain a required speed, and we have also determined the back EMF and power rating of the motor. So today's topic will be on dual converter fed separately exited DC motor drive. By the end of this session, you should be able to appreciate the use of dual converters as compared to the controlled rectifiers, and you should be able to solve numerical problems and determine firing angle, speed, back EMF of dual converter fed DC motor drive. Dual converters can be designed for single phase or three phase. First, we'll see the single phase dual converter drives. Uh, in some industrial applications, DC motor may be required to operate in four quadrants. So the four quadrant operation of inverters, that is forward motoring, forward regenerative braking, then we have reverse motoring and reverse regenerative braking. So when the motor is operating in forward direction, it is to be required to be stopped, and hence we require forward reverse braking operation. That is first and second quadrant operation. But in some cases, all the four quadrant operations may be required to be met. So we have seen that a single phase bridge rectifier, if I use for the speed control of the motor, it can operate in first and fourth quadrant. And it is possible that if I connect the converter in the reverse direction to the motor, we can get the second and third quadrant. So that purpose is now used in dual converters, wherein a dual converter has two controlled rectifiers. For example, bridge 1 and bridge 2. We can also call it as converter 1, converter 2, or we can call it as the P converter and N converter. P converter and N converter. So here, as you can see in this figure, that converter 1 or bridge 1 is connected in a normal way to the motor, and there is another converter, N converter, which is connected in reverse direction. So this connection is called as anti-parallel or reverse parallel connection of converters. So we are using two bridge converters which are connected in inverse parallel, and that is those two converters will be supplying power to the DC motor. Uh, so in if when two converters are used, then these two converters will be operating. These two converters will be operating in two different directions. So one bridge will give the current in one direction. The other bridge will give the current in the opposite direction. So as you can observe from the voltage current uh, levels and the polarities of operation, we can see here that when bridge 1 is operating, same current direction is maintained. Let us say P converter is giving positive current. So this P converter will be operating in the first and fourth quadrant. The other bridge which is connected in reversely gives reverse current, and hence when the current is reversed, it will be operating in second and third quadrant. When these two converters are acting to, then there will be difference between the instantaneous currents between bridge 1 and 2, and hence care must be taken that these two converters should not be operated at simultaneously. If they are operated, external inductance should be added here at the junction to limit the circulating current. Yeah. So if, for example, the speed reversal is to be implemented, speed direction is to be reversed in case of the uh, DC drive, then what is to be done is first Firing pulses to the bridge 1 is stopped. Then give some time for the current to become 0. Then after some time gap of milliseconds, second bridge is turned on. You should not turn on the second bridge immediately to change the reverse of direction of speed. You have to give some time lapse. So this is how the technique is used for the P converter. So when bridge 1 is operating, the average output voltage is given by 2 Vm by pi into cos alpha 1, and that is nothing but Vd naught into cos alpha 1. What is Vd naught? Vd naught can be taken this 2 into Vm by pi. So by seeing the network connection, this by and applying a KVL, we can see that this average output voltage is equal to back EMF plus I into RA drop. Similarly, when bridge 2 is operating, the average output voltage is given by Vd naught into cos alpha 2, and by substituting the cos alpha 2, we can see that this gives a negative value. This gives a negative value. The average output voltage becomes a negative. Then this can be given by Ea minus Ia1 into Ra. So you see here this for forward motoring operation, it is Ea plus Ia into Ra. For forward braking operation or when second bridge is operating, it is Ea minus Ia into Ra. So you can see here the thing whatever we have explained. Let us say the motor is operating at this operating point A, and the speed of this one is to be reversed and moved to this operating point, let us say B. So from A to B it is not directly moved. So what is done is bridge 1 was operating here. Gradually this current is made 0. So here you can see this is torque 0 line or current 0 line. So current is made 0, then bridge 2 is turned on so that the operating points shift to this, and then gradually the firing angle value is changed to move on to this operating point. So the operating point moves from A to C, then to D, and then to B. Okay, this is how it is done, because of which there is a time lag of operation for moving from A to B. So similarly, we can also design the dual converter with the same logic for three-phase system. So three-phase dual converter drive. Supply is a three-phase, output is DC, and that is connected to DC motor. So here again you can see here P converter 1 and N converter is there, and in between this external inductance can be added to limit the circulating current. When this inductance is added, there is possibility to operate these two converters simultaneously. If these two converters operate simultaneously, then you have to take care that if for example alpha 1 is the firing angle of converter 1 and alpha 2 is the firing angle for converter 2, we have to see that alpha 2 is pi minus alpha 1. So what does this give now? If I take alpha 1 to LHS, it becomes alpha 1 plus alpha 2 is equal to pi. So because of its reverse direction, it is given a 180 degrees delay. So alpha 1 and alpha 2 addition should be equal to 180 degrees. So for three-phase converter, for bridge 1 operating, V average 1 is 3 root 3 Vm by pi into cos alpha 1, and for bridge 2 it is 3 root 3 Vm by pi into cos alpha 2, which results into negative value. So here we have Ea plus Ia into Ra, and for the second converter we have Ea minus Ia into Ra. So this is the now, because same rules holds good, that if dual convert is used, we can operate with any of these four quadrants. As you can observe here, converter 1 is operating in first and fourth quadrant, and converter 2 is operating in second and third quadrant. So based on the based on the conduction of the converters, we can have two types of operation of dual converter. One is circulating current mode, and the second one is non-circulating current mode. In case of circulating current mode, external inductance is used like this. External inductance is used in between the two converters and to the motor connection. So with this, what happens? You can limit the circulating current. So you are limiting the circulating current by using reactors. Because of this reactors, the response will be slow and hence the efficiency decreases. Because of the inductor and the circulating current, the total efficiency of dual converter will be less as compared to non-circulating current mode. So what is the advantage of this one? Continuous bridge current is maintained, and hence as the current is continuous, there is no discontinuity, and hence there is no torque pulsations and speed oscillations of the motor. In case of non-circulating current mode, only one converter is operated at a time. Two converters are not switched on at the same time. In case of circulating current mode, two converters are turned on simultaneously, and you have to see that alpha 1 plus alpha 2 is equal to 180 degrees. But in this case, two converters operate separately. So discontinuity occurs when the discontinuity occurs when the load current is very small and inductance is very small, current becomes zero, or discontinuity will occur when there is a transition from one converter to another converter. But the advantage is high efficiency is there, and disadvantage is the dead time or the discontinuity. Yeah. So I appeal students, please go through this problem. You can go through this problem and read. Here it is asked to determine the firing angles of the converter, back EMF and machine speed for forward motoring condition and also forward generation. That means forward regenerative braking condition. Yeah. So steps are given. Please go through that one. So okay, dear students, uh, in this session we have seen the equations for average output voltage of converter 1 and converter 2, and we have seen the quadrants of operation of the drive when dual converter is used, and a numerical problem to calculate firing angle, speed, back EMF for a DC motor supplied with a dual converter. Okay, these are the outcomes. Please go through. And additional numerical problem is given. You can solve this. So refer this chapter 5 of GK Dubey, and you can refer to these sections. And an example is given the solved problem. And based on your knowledge, then go on to solve for the exercise problems 5.45 and 5.46. Thank you, students.